All right, so for investigation 3.4, your work on Tuesday, you are expected to learn some strategies for solving quadratic relationships. And in the past, you have found that you have to satisfy a couple requirements before you can solve a quadratic. For instance, your quadratic must be, and that is the biggest, must be, so the expression must be equal to 0. And you must have your expression in factored form. And again, it has to be equal to 0. So if you start out with a non-zero number, you need to use your normal algebra, your train tracks, to move what's on, to move things all together on one side. So let's see what the connected math makers gave for you today. All right, so you had to, in question A, write the expanded form expression into factored form, and then you are to solve that expression. In question B, you have 6 problems, and notice how they're all equal to 0, so that makes things super convenient for us. And then finally for C, more solving. I believe we had a D, so we'll get to all of them. Here we go. For question A, we need to write that in factored form. So we are looking for factors. Well, first thing, is there a greatest common monomial? No. Is this the difference of squares? No, it's trinomial. Is it a square binomial? No. 24 is not a perfect square. Therefore, we have to look for a binomial pair of factors. There's the a value is 1, so all we need is a factor sum table. So we have factors of 24, and we're looking for a sum of 10. And I know off the top of my head that 6 times 4 is 24. 6 plus 4 is equal to 10. So I have a winner. So we have the expression x plus 6 times x plus 4 is equal to 0. Well, let's take each one of these pieces by themselves and solve them just like any other problem that we would solve. The opposite of adding 6 is subtracting 6. So we get negative 6 is equal to x. On our other side, minus 4, and we get x is equal to negative 4. Ta-da! Now, that would relate to the x-intercepts of your parabola. So this graph would look something like this, where this is negative 4, 0, and this will be negative 6, 0. Obviously, that would be negative 5. And no, this is not to scale. For question B, so in order for us to have a quadratic solution, we need it in factored form and equal to 0. So right away, I see that these two are already equal to 0. Please resist the urge of multiplying them. We don't want that. That would give us expanded form. We don't want expanded form. We need factored form. So we're going to break things apart, set both sides equal to 0, because it's already equal to 0. The opposite of adding 1 is subtracting 1, and so I get negative 1 is equal to x. On this side, slightly longer, minus 7, so we get 2x is equal to 7, negative 7, divided by 2, and I get x is equal to negative 7 over 2. So here are my two expressions, or two answers rather. For this problem, same idea. We're going to set both things as equal to 0, because it's already in factored form, and it's already equal to 0. So the easiest thing to do here is to add x. So I get x is equal to 5. Over here, let's add 2. I get x is equal to 2. There's my solutions. Now, the reason why I added x instead of subtracted 5 is because then it reduced the number of steps I needed to have, because it gave me an x that was positive. Let's take a look at 3 and 4. Well, they're not quite as easy as the first two because they're an expanded form. However, we are equal to 0. So all we need to do here is factor. Well, is there a greatest common monomial? No. Is this a difference of squares? No, it's all adding. Difference means subtraction. Is this a square binomial? Well, we have an x squared. We have a 9. Those are both perfect squares. So this could be a square binomial. So we have 0 is equal to, now if it's a square binomial, all we'll have to do is square root the x squared, which is x, square root the 9, which is 3, and we have 2 positives, so this has to be a positive squared. Now we're not able right now to say that that is correct because we need to double check to make sure the linear term works. So we have our a value, we have our b value, and we know that the linear term is going to be 2 times a times b. Okay, 2 times x times 3 is equal to 6x. Oh, we have a winner. So we have our expression factored. Excellent. Well, what's the opposite of squaring? Square rooting. Yes, that's right, square rooting. So we will square root both sides. The square root of 0 is 0 because 0 times itself is 0. And then we have x plus 3 squared, and we're taking the square root. Well, that's just x plus 3. Because x plus 3 squared means x plus 3 times x plus 3, and we're taking the square root of it, which is what can what two numbers multiplied by themselves will get to my original. So clearly, we just end up with x plus 3. Minus 3, and we get x is equal to negative 3. Incidentally, this will have a graph that looks like this. It will be a parabola that has its vertex at negative 3, 0. For problem number 4, all right, not in factored form, we'll forgive, but it is equal to 0. So let's use our factoring checklist. Greatest common monomial is greatest, no greatest common monomial. Number 2, is it a difference of squares? Well, 16 is a square. X squared is a perfect square. We're subtracting them. We must have a difference of squares because difference means subtraction. So I know a difference of squares will be factored with a pair of binomials. One will have an addition sign, one will have a subtraction sign. And now, what times what is x squared? Well, x times x. What times what is 6? 4 times 4, 16. And so this is equal to 0. And let's break it apart. And minus 4, and we get negative 4 is equal to x. On the other side, add 4, and we get x is equal to 4. All right, for number 5, we have no greatest common monomial. This is definitely not a difference of squares because it's a trinomial. It's not a, and it's addition. We have could be a square binomial. Well, let's try. So if it's a square binomial, we would have x plus 4 squared. Now for it to be a square binomial, this term here has to be 2 times my a value times my b value. Okay. So 2 times x times 4, that's 8x. That's not 10x. Oh, shoot. So that doesn't work. So now we're left with finding the binomial pair of factors. That's just the table, or if you'd rather do the rectangles, that's fine. So I'm looking for factors of 16 that have a sum of 10. Well, 4 times 4 is 8. 2 times 8. That's right. 2 times 8 is 16. But 2 times 8 is 10. 2 plus 8 is 10. So my sum is 10. All right, great. So that means we have x plus 2 times x plus 8 is equal to 0. Set both sides equal to 0. And clearly, we will figure out that x is equal to negative 2. Over here, we'll have x is equal to negative 8. Finally, for number 6, there's an a value bigger than 1. I hate it when that happens. Well, that means we are going to have to do a possible factor sum table. So, all right. So here's how I do it. I'm going to write 2 as a factor pair. So 2 times 1 is 2, right? Well, 6 can either be 1 times 6 or 2 times 3. And so here's what I'm going to do. I notice that I have an plus 6 for both of these, right? Which means I need to multiply one of these numbers with one of these numbers, multiply the other number by the other number, and add those two products together to get 7. So that means when I multiply the 2 to something here, it has to be less than 7. Okay, well, 2 times 3 is 6. That's less than 7. That would leave us 1 times 2, which is 2. 2 plus 6 is 8. Doesn't work. But I know that 2 times 2 is 4. And 1 times 3 is 3. And 3 plus 4 is 7. All right, so that means I have to multiply my 2 and my 2 together. So we have 2x and 1x, okay? And then the 2's have to be multiplied together to get this linear term. So that means that this 2 has to be down here. And that means the 3 has to go here. And there we have it. Okay, excellent. So we're not done yet because we're being asked to solve. So set it equal to 0. And obviously this is going to be x is equal to -2. On this side, it may not be quite as intuitive. So let's subtract 3, and I get -3 is equal to 2x. Divide by 2, divide by 2, and I get -3/2 is equal to x. All right. So go ahead to the next video for problems C and D.